Welcome to today's Deep Dive. I'm your host, and with me is our resident expert. And today we are getting into something pretty wild.
Yeah, hi everyone. I'm really excited about this one. It's definitely a unique topic.
It really is. So to kick things off, in the year 2025 alone, there's this independent creator, right? His name is Qianmeng Ang, and he published 730 incredibly dense, highly technical blog posts.
Which is just a staggering amount of output.
Think of that for a second. That is 2 full posts a day, every single day of the year, without fail.
Yeah, the sheer discipline is amazing.
Right. But here is the kicker. He wasn't just writing about complex software code or like server architecture.
Yeah.
He was writing about debugging fish.
Right, which sounds like a joke, but he is completely serious.
He really is.
Yeah.
Our mission for today's deep dive is to explore how the analytical mindset of a software developer can completely transform how we approach our physical everyday hobbies.
And to understand why this matters and why we are looking at this specific material today, we really need to establish who the author is.
Right. Context is key here.
Exactly. So he describes himself as an old software plumber who spends his nights tinkering with floss.
Which, for anyone who doesn't live and breathe developer jargon, what does FLOSS actually stand for?
So it stands for Free, Libre, and Open Source Software.
Okay, and we should clarify what that actually means in practice, right?
Yeah.
We're talking about software that is entirely open to the public.
Yeah, exactly.
So anyone could just go in, look at the code, modify it, iterate on it, and hopefully improve it.
Right. It's this incredibly collaborative, just relentless cycle of finding bugs and patching them.
And what we're looking at today is what happens when you take that exact mindset, that really analytical, hyper-organized developer brain, and you force it into the messy, unpredictable physical world.
It completely transforms how we think about a hobby because we are diving into a specific post of his titled Notes on Fishkeeping, Part 210.
Part 210.
Yes, Part 210. I mean, he meticulously documents his offline pursuits with the exact same rigor he applies to software. So he documents things like gardening, meditation, and, in this case, outdoor fish keeping.
You know, the best way I can describe his blog to you, the listener, is to imagine a brilliantly organized, just massive filing cabinet. But it belongs to this relentlessly curious mind.
That's a great analogy.
Because, like, think about most people's hobbies. They look like a chaotic workbench, you know?
Oh, absolutely.
You have potting soil spilling over the edge, maybe some tangled fishing line somewhere, half-finished projects, just gathering dust.
My garage is basically exactly what you're describing right now.
Right. But for Qianmeng, every single seed he plants or every single fish he feeds is documented like it's a crucial line of code in a sprawling software program.
Which brings us to this really fascinating cross-disciplinary mindset. If you spend time in the projects and archives section of his blog...
Which we highly recommend doing, by the way, just to witness the scale of it.
Yeah, you really should. But you see him bouncing effortlessly between these highly abstract digital concepts and literally just dirt.
Literally dirt.
Yeah.
Uh-huh.
You will find a post titled Notes on Haskell Programming sitting right next to his notes on gardening.
And let's give a little context there, because Haskell is an incredibly complex, purely functional programming language.
Right. It's highly mathematical.
Yeah, very abstract. And he is jumping from that, or from these other deep dives into complex languages like Elixir and Rust, straight into, like, notes on dieting.
Or documenting the propagation of his crown of thorns plant.
Yes. He even has a whole series he calls his Bougainvillea Journeys.
Which I love. It shows us that he doesn't just switch his brain off when he steps away from the keyboard.
No, not at all.
He applies a strict engineering framework to absolutely everything. He treats biological variables identically to code variables.
Okay, meaning?
Well, meaning if a piece of software crashes, a developer looks for the bug, right?
Right.
So if a bougainvillea plant suddenly drops its leaves, or if a fish pond suddenly requires way too much maintenance, he treats that as a physical bug.
He isolates the variables.
Exactly. Sunlight, water quality, temperature, and then he iterates.
Okay, wait. I need to challenge this approach for a second.
Sure, go for it.
Because when I hear about applying rigorous daily documentation to what is supposed to be a relaxing weekend hobby, my immediate thought is that it sounds exhausting.
That's fair.
Like, is it possible to completely over-engineer a hobby? If I am stressed out at work all week and then I go into my backyard and I have to start logging water pH data into a spreadsheet.
You're doing more work.
Yeah. I'm not actually enjoying nature anymore, am I? I'm just doing data entry in my backyard.
Right.
So doesn't this hyper-analytical approach strip the actual joy out of just sitting back and watching the fish swim?
That is a completely natural reaction, especially if you view hobbies strictly as passive relaxation.
Right, which most of us do.
Exactly. But this raises a really profound question about how different minds achieve a flow state.
Oh, interesting. Okay.
For a software developer who's heavily involved in open source projects, the joy rarely comes from the finished, static product.
Because the product is never really finished.
Right. The joy is generated by the act of iteration itself, the tinkering, the measuring, the adjusting. That is the relaxing part for him.
But doesn't the constant need to, like, optimize everything interrupt the peace of the environment? It feels like you're never allowing the system to just exist. You're always looking for a flaw.
Well, think about it this way. By documenting these variables, he is actually removing the underlying stress of uncertainty.
Okay, how so?
Nature is incredibly unpredictable, right?
Yeah.
A sudden algae bloom can wipe out an entire fish tank in a day.
Oh, wow.
Yeah, and if you don't know why it happened, that is a highly stressful, helpless feeling.
Because you're just at the mercy of the elements.
Exactly. But by logging the data and treating it as a system, he turns an unpredictable act of nature into a mechanical process.
Something he can actually understand.
And predict and ultimately improve. The documentation is the hobby just as much as the fish are.
Okay, that actually reframes it for me. The peace comes from the comprehension of the system, not just looking at it. So let's look at this physical debugging process in action. Let's dive right into the specific troubleshooting ticket he is facing in part 210 of his notes.
Right, so setting the scene for this specific entry, the author is dealing with a classic scaling issue.
A scaling issue in his backyard.
Yeah. The variety of fish species he is breeding outdoors is growing, and it's growing successfully.
Which is a good problem to have.
It is, but because the population is expanding, he needs to expand his infrastructure. He needs more outdoor breeding ponds.
And he doesn't just, pull out his credit card and order a massive, expensive, custom acrylic aquarium setup.
No, of course not.
He conducts an audit of the resources he already has lying around his home.
Right, the open source mindset.
Exactly. And he decides to utilize some spare EPS foam boxes that are currently underutilized.
And we should definitely clarify what EPS foam is, because it is central to why this problem even exists.
Yeah, go ahead.
So EPS stands for expanded polystyrene. Basically, we are talking about those thick, white styrofoam coolers.
Like the ones you might use to keep drinks cold at a picnic or a tailgate.
Precisely. And in the context of outdoor fish keeping, especially in a tropical climate, these boxes are actually brilliant.
Because they act as thermal insulators.
Exactly. If you put a thin plastic tub of water out in the direct tropical sun, the water is going to heat up rapidly.
And literally boil the fish.
Yes, literally boil them. The EPS foam prevents those massive temperature swings. It keeps the environment stable.
Okay, so they're great insulators. But
in attempting to set these foam boxes up as breeding ponds, Qian Meng identifies two major pain points.
Two critical bugs in his physical hardware.
Right.
So bug number one is a scaling problem related to volume.
Yes.
He notes that the smaller foam boxes require significantly more maintenance than the larger ones. Specifically, they require much more frequent water changes.
Which brings us to the underlying biological mechanisms at play here. This isn't just about the water looking a little cloudy.
No, it's way more serious than that.
Yeah, it is about the bioload and the nitrogen cycle. So, fish eat protein-rich food, and then they excrete waste.
Right.
That waste breaks down into ammonia, which is highly, highly toxic to aquatic life.
So how do fish survive in the wild?
Well, in any established aquarium or pond or in nature, you have beneficial bacteria that consume that ammonia and convert it into less harmful compounds.
Ah, okay. But the volume of the water dictates how forgiving that biological system is, right?
Exactly.
I mean, think of it like putting a single drop of red food coloring into a tiny teacup versus dropping that same single drop into an Olympic-sized swimming pool.
That's a great way to visualize it.
In the teacup, which represents our small foam box, the water instantly turns red. The toxicity concentrates immediately because there is no buffer.
Right.
But in the swimming pool, that drop disperses safely and you wouldn't even notice it.
And that is a perfect analogy for the bioload. Because the smaller foam boxes lack water volume, the toxic ammonia builds up incredibly fast.
The teacup turns red almost instantly.
Exactly. The biological cycle simply cannot keep up with the waste production in that small of a space.
So what happens?
Well, the only way to prevent the fish from dying is human intervention. You have to manually remove the toxic water and replace it with fresh water constantly.
And that introduces the most dreaded variable of all, human labor.
Oh, yeah.
I mean, you know that feeling when you have a household chore that maybe only takes 15 minutes, but you dread it so much you put it off for a week?
Like folding laundry?
Yes. Or emptying the dishwasher. That is the exact human variable Qianmeng is trying to engineer out of his system.
Because manual water changes are messy.
Very messy. You're scooping water out with a bucket, you're splashing it on your shoes.
Just stressing out the fish who are darting around trying to hide from the bucket.
Right. It's a high-friction chore. It's like having a smartphone app that constantly drains your battery, and you just have to keep plugging your phone in every 2 hours.
Yeah, and the friction compounds. If you are breeding multiple species across several small boxes, you are suddenly spending hours every week just bailing water.
Just bailing water with a bucket.
Right. So that is the first bug, the maintenance bug.
Okay, what's the second bug?
The second bug he isolates is environmental. He notes that the physical placement of these boxes is a critical variable.
Because it directly impacts the growth of the aquatic plants inside them.
Right.
The sunlight variable.
Right.
Like, if they are in the shade, the plants die and they stop filtering the water.
Yeah.
But if they are in direct sun, you get massive algae blooms.
Exactly. So he is trapped in this fascinating bottleneck. He has these highly efficient insulated foam boxes that protect against temperature swings.
That is great.
But their small volume is creating a biological crisis that demands constant, annoying manual labor.
And he refuses to just throw money at the problem by abandoning the boxes and buying a massive tank.
Because that would defeat the whole purpose of his ethos, right?
Right. So how does an old software plumber patch a physical bottleneck in his backyard over a long holiday weekend?
Well, this brings us to the observation and prototyping phase.
He doesn't just accept the friction.
No, he decides to alter the hardware. He comes up with a new design prototype for these EPS foam boxes.
Okay, what does he do?
He outlines two distinct, highly intentional engineering upgrades. Modification number 1. He plans to attach a faucet directly at the bottom of the foam box.
Okay, let's break down the why and how behind this. Because while installing a faucet sounds like pretty basic plumbing,
It is basic plumbing, yeah.
in this context, it is a masterstroke of passive automation.
It completely revolutionizes the mechanics of the maintenance. We talked earlier about the messy, stressful process of scooping water out from the top with a bucket, right?
Right, the splashing and the stressed fish.
Well, by installing a sealed faucet at the very bottom of the box, he leverages simple physics. Gravity does all the work.
When it's time for a water change, he doesn't have to disturb the surface at all.
Not at all.
He doesn't stress out the breeding fish. He just walks over, turns a small valve, and the toxic ammonia-heavy water, which, by the way, tends to settle near the bottom anyway, along with the solid waste, it simply drains out.
Right into a bucket or a drain.
Yeah. He has taken a manual, labor-intensive, high-friction chore and turned it into a passive, streamlined system.
He successfully engineered the human labor variable down to almost zero. He patched the internal maintenance bug.
That is so satisfying.
It really is. But the second upgrade is where you really see the systems level thinking shine through.
Oh, yes.
Modification number 2. He adds a specific drainage hole near the top of the foam box.
And the source material gives us a really vital piece of context for why this top hole is necessary.
Yeah.
He writes that the drainage hole is there to handle overflow, quote, given our unpredictable tropical rains.
And this elevates the design from a clever DIY project to a robust, closed system architecture.
Right, because if the bottom faucet solves an internal system issue, the biology and the top drainage hole is designed to solve a catastrophic external threat.
Yeah, we really have to establish the stakes here. If you are breeding fish outdoors in a tropical climate, a monsoon isn't just an inconvenience.
It is a system-wiping event.
Completely. If a massive rainstorm hits overnight, a closed foam box without a drain is going to fill up rapidly.
And it'll just flood continuously over the top rim.
Right. And when it floods over the rim, your selectively bred fish, your carefully cultivated aquatic plants,
all of it literally washes away into the grass.
The entire generation of fish is lost. It's game over.
So the top hole is not just a drain. In software terms, it is an error handler.
That is exactly what it is. In software development, you always have to build in contingencies for unpredictable user inputs or sudden server outages.
Right, like if a website goes viral.
Exactly. If the server gets flooded with traffic, how does the system route that traffic so it doesn't crash?
So in outdoor tropical fish keeping, Qian Meng has to account for unpredictable environmental inputs, like a massive rainstorm.
Right. And by drilling a specific overflow hole at a precise height near the top, he dictates the exact terms of the flood.
So when the torrential rain hits, the water level rises to that hole and safely exits.
While the fish remains safely contained below the waterline, he has created a fail-safe.
It is the definition of elegant simplicity.
It really is. I mean, it costs almost nothing to implement.
And it utilizes fundamental physics. Gravity pulling the water out the bottom faucet and gravity pulling the excess rain out the top overflow.
Yeah. And with those two small physical edits, he completely neutralizes the two major bugs that were preventing him from scaling his breeding operation using recycled materials.
It's just brilliant. And this is where I really want to connect this directly back to you listening right now.
Because it's not just about fish.
Exactly. Because you might be thinking, look, this is a great story about a guy in a tropical climate breeding fish in styrofoam coolers. But I live in an apartment, and I don't even own a goldfish.
Right. Why does this matter to me?
Exactly. Why should you care?
Well, it matters because of the framework. We all have friction points in our daily routines. We all have systems that are quietly draining our energy.
Think about the physical spaces you interact with every single day. Where in your life are you constantly bailing water with a bucket when you could just take an afternoon to install a faucet?
That's the real question. Because we tolerate so much inefficiency simply because it is the way we have always done things.
Oh, 100%.
It is the laundry basket that
Right.
is kept in the bedroom when you actually take your clothes off in the bathroom.
Meaning you have to carry dirty clothes across the house every single night.
Right. Or it is the way you organize your digital desktop so you spend 5 minutes searching for the exact same document every morning.
Or the fact that you have to physically unplug and move 3 different kitchen appliances just to plug in your coffee maker.
Yes, exactly.
We accept these high-maintenance, small foam boxes in our lives as inevitable annoyances. We complain about the chore, but we don't fix the hardware.
But Qian Meng's approach is a challenge to stop. Observe that friction, isolate the variable, and build a quick prototype to patch the bug.
It is a masterclass in auditing your environment.
It really is. Ask yourself, what resources do you have lying around that are currently underutilized?
And what small, seemingly insignificant modification could you make this weekend that would save you dozens of hours of cumulative manual labor over the course of a year?
When you zoom out and view Notes on Fishkeeping, Part 210, alongside his 729 other posts from that year,
Spanning Haskell programming, network infrastructure, and bougainvillea propagation.
you realize it is all driven by a singular, relentless curiosity. It is the profound belief that nothing around you is ever truly finished.
The world is just a series of prototypes waiting for the next iteration.
Which brings us right back to the foundational philosophy of FLOSS, free and open source software.
Right.
The entire ethos of that community is that a system is never locked. It is entirely open to being viewed, dissected, modified, and improved by anyone willing to look at the source code.
And what Qian Meng has done so brilliantly is rip that philosophy out of the digital realm and apply it directly to the physical dirt and water of his backyard.
He treats his physical environment as open source.
And that framework is available to anyone. You don't need to know how to code in Rust or Elixir to apply an engineering mindset to your kitchen counter.
Not at all.
Which leaves us with a really provocative thought for you to take away and mull over today.
Yeah, think about this.
Think about the daily routines, the physical spaces, and the habits that make up your life. If you started treating your physical environment as an open source software project that is completely open to your own constant iteration and user modifications, what outdated legacy code in your life would you finally rewrite today?
What is the one messy, labor-intensive process in your daily life that you would finally sit down and debug?
Don't be afraid to pull open a drawer in that massive filing cabinet of your mind and completely reorganize it. Look for the friction and build your own faucet.
I love that.
Thank you so much for joining us on this deep dive. Keep exploring, keep tinkering, and we will catch you next time.